Hello and welcome. In this video, we're going to discuss series current. Series current has one path, which means that every one of these resistors will have the exact same current flowing through it. And we're going to call that current IT. And that tells us that the total current is the same through every one of our components. The current through the first resistor, the second resistor, the third resistor, and however other many series resistors that we have, the current will all be the same for them. That means that total resistance is required to determine the total current. Right? We also note that the positive lead of our battery source tells us the direction of our current, right? Because current flows from positive to negative terminals of our battery. So the long leg of our battery here is going to be the positive side, and that's going to flow all the way around to our negative side or ground location. Oftentimes we'll even have a ground at the bottom here to identify the fact that that's a 0 voltage location. So we are going to solve for total current in this circuit. So to do that, we need to determine the total resistance, RT, and that's going to allow us to use Ohm's law here to determine the current. Current is equal to voltage over resistance. So that's what our final goal is. I is equal to voltage over resistance. And specifically, if we're going for total current, we need to have the total voltage and the total resistance. So we do have that. We have 25 volts, that's our total voltage. VT. It's also called voltage source, VS, and those are the same thing. So we need to solve for our total resistance, and we can plug that in. Watch out for this kilo ohms value at the top. All of these are in mega ohms, and so we want to make sure that that other one gets accounted for correctly as well. So it's at the positive 3 location. We can move it forward 1, 2, 3, and place it at the positive 6 location. So it's 0.723 mega ohms. Now we can add them all up. So we'll pull out our Desmos. We can say that we have 0.723 plus 24.6, those are both in mega ohms, plus 35.4 mega ohms, plus 11.3 mega ohms, and we're left with 72 mega ohms. So our total resistance, RT, is equal to 72 million ohms. Right, now we can plug it into our Ohm's law equation here that says our voltage, 25 volts, divided by our total resistance, 72 mega ohms, is going to equal our total current. Let's solve that here. We can plug that into our Desmos. 25 divided by 72 million, right? 72 times 10 to the positive 6. There we go. So we're given a weird number there. Our IT is equal to 3.47 times 10 to the negative 7, right? That's not an engineering notation because it's not a group of 3. That negative 7 location doesn't work with engineering notation. So we can either move it down 1 and get it to the negative 6. We can write that as IT is equal to 0.347 times 10 to the negative 6 gives us a microamps. Or we can do it the other way. We can say that we have IT equal to, and we can move it back from negative 7 to the negative 9, back 2. So that gives us a 347 nanoamps. Both of these two currents are correct. Right? Let us know if you have any questions.